Greetings. Let's get this party started. So from the last session that we had, and you can review the recording on YouTube. We got to this point where we had made a bank. We had given it some private parts. We had given it this cap account, so the capacity of the accounts that the bank could hold. So as you could hold more bank accounts, you would just go in and increase this number, and that would affect the change throughout the entire class. Maybe the bank has a limitation by federal law or state law or whatever on the number of accounts that they can hold. And so as they get approval for more accounts, they would just go in here and change it. But then you also need to keep track of how many open accounts. So this is the same thing as that partially filled array problem that keeps popping up, and it's going to keep popping up. Is that we need to keep track of, how many elements can we store, and then how many elements are we storing right now. And then we make this array of bank accounts, bank account or bank accounts, and we're calling it accounts. And we're making it of the size of the capacity. And then we have a default constructor that just makes sure that open accounts is 0. But maybe you wanted to, if your bank had rules for accounts, that accounts had to have a certain sequence of numbers, or that they had to start with a starting amount, then what you could do here is that in the default constructor, you could create all of these. When you go to create all of these bank account, you could create all of them, stuff them in the array, and make them have certain attributes. So set that value, set those account numbers in advance, and then when somebody comes in to open account, you already know what the number and the amount that they have in the account is going to be when they're starting out. So that would be an example of what you would do in a default constructor besides just this. And this is also sort of unnecessary. But yeah, so any kind of setup that you would want to do, you do here. And then we have some methods. We have this open bank account here, and we want to make sure that that we're not full, that the bank hasn't made all of the accounts. And in this case, we're just going to return -1. Otherwise, we would return maybe the bank account number. When somebody opens a bank account, right? When you go in and open a bank account, they typically give you a little card or something that has the your membership number or your bank account number written on that card. So essentially, this method is going to do the same thing. And maybe, and we'll learn about this later, or if you've watched the lecture from before, we might throw an exception as well. And Java has a ton of pre-made exceptions that we could look through and see if there's something that makes sense there, and then throw that as an indication that that we've reached our capacity in the number of accounts that we can make. And then in the open account, we would have some kind of information. Maybe we have a bank account default constructor that just makes a blank bank account, or we could have an overloaded one that uses a ton of uses all of the stuff to set up their name, their account number, some IDs, sub accounts, whatever it might be, their balance that they initially deposited, things like that. So we have this to-do message that's written for us, and actually let's make it proper, something like that. Where here we would have a scanner. We would have a scanner. Yeah, maybe we have a scanner object that we create. Or what we could do is that the main that calls open account, we could have all of the parameters given to it. So we could change the behavior of this method depending on if we wanted to run it in where it itself collects the input. Maybe it opens a file and collects input, or that it's handed all of the information that it already needs to create the bank account. So you could have multiple versions of this method. You could overload it so that it could do those different behaviors. And then we have another one that's a get bank account. So the idea being is that the index in the array of the bank, so this array here, accounts, the index doesn't really mean anything, right? When you walk into a bank and you say, hey, my account number is blah, 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 they're not just going to that spot in the array, in their array to access it. That they have some kind of database that has some kind of key or structure or whatnot that isn't necessarily just accessing it in an array, that it has to essentially go through and find that account. And they may have more clever ways of looking it up, but the order in which your membership number isn't the index in an array. And so what we have to do is we have to iterate through all of our open, in this case, we have to iterate through all of our open accounts, get the account number, and then check if it's the account number that was provided. So in this case, if you had 100 accounts and your account happened to be the last one, then this for loop is going to have to run the whole way. But if it happens that your account happens to be the first one, then the for loop is in the first run. This is true, and then we return immediately. The beautiful thing about methods or just functions in general is that you can return immediately when you know the answer. So we don't have to run, this for loop could run once. It could run, well, actually, if you have no open accounts, right, then it would run never. Right, because 0 is not less than 0. So it would never run. And then in this case, that behavior is sort of unexpected. If the bank account, if somebody walks in with a membership number and they don't exist, maybe we have an exception for like doesn't exist, or in this case, right now it's just creating a new bank account and handing it off, which may not be what you want, because maybe then you try to interact with that, like you make a deposit with that bank account, and then that money goes nowhere because you never bothered to save that bank account. That bank account only exists within main or whoever called this get bank account. So sort of a dangerous place to exist. But right now, that's sort of what we just cobbled together in the last session. So we have done all of this without creating a bank account class. So let's just do that real quick. So let's just start with our generic starter code. And we got to rename this guy. And I don't trust myself to type, so I just copy pasta all this. And okay, so, and we don't need a main. And actually, we don't even need a scanner, so I could have just retyped this, but I don't trust myself to type. So we have a class called bank account, and so we're going to need the default constructor that we're using here. So we'll just immediately just write that. But then if we go to our slide, that bank account needed a few things. And if you just stop and don't look at the slide and just think about it, that there are some things that it makes sense to have in a bank account, right? That when you give somebody a membership number, that they can then they know what your name is, maybe your address, so that they have a lot of information that's already associated with that to be able to verify that you are who you say you are. So in this case, let's just stick with name, account number, and their balance. That those are just 3 reasonable things to store. And so when we look at those types, it's really important that we think about, well, what is those variables? What is the type that we would use to store those? And we should also think about what is the smallest type, and does it make sense, depending on the context of however you're using it. So your name, typically your name is more than 1 character. And so a string is pretty much what we're stuck with here. So we have our string, we'll call it name, And then you have your account number, and the account number, it's probably an unsigned number, but maybe we need to have some way of being able to return -1 right here as an error state. So we have this account type, this account number type, and it's negative, which is this is an invalid state. But maybe we store that, maybe we end up opening an account and storing that. We want to be able to do that without really strange errors. So we might make our account number an integer. Oh, my internet connection is unstable. That's fun. Hopefully this recording doesn't get much up. So the account number is probably going to be unsigned, but we've already seen an example just in how we use it in the bank class that we do return a -1 for an account number to indicate that it's an invalid account number. And so for this case, I'm lazy. We're just going to make it an int. But that's just something that you should think about whenever you're making variables. And then balance. And what about balance? What money, right, is not going to be an integer. And depending on the kind of bank, you might have a negative balance. Right? Maybe you have just a normal debit card where you stop at 0. But if we're going to generalize this bank account for the balance, we need to be able to have negative numbers. So it's not going to be unsigned. It's going to be signed. And the thing that a lot of people forget when they're making accounts like this is that they forget that the balance has decimal places, right? You have your dollar, not only your dollars, but you also have your cents. And some people will split it up. They'll split up the dollars and cents into separate variables. The issue with that is that messes up some of the math when you're calculating interest, or it makes the math a little bit more complicated. And it's just not worth the effort. In most cases, it just makes a lot more sense to store the balance as a double, or as some floating point number. And a float, we've already seen the problems with floats towards the beginning of class. So we should probably just use a double. Oops. Cool. And so maybe as the default constructor, whatever, I can't spell. So as the default constructor, right, we want to set these things. So like name is going to be none, right? We're just setting things up. Maybe here we again use that invalid state of -1 to indicate that this account has not been assigned an account number, and let's just set the balance to 0.0. Right, so there's our constructor. Cool. And then we have some methods down here. Oh, actually, let's make the other constructor. So this is our default constructor here. And then we need our overloaded constructor. So the overloaded constructor is going to take in the new name, and this is where I'll remind you that new is a reserved keyword in Java. So notice that just like new by itself is colored, just like the types up there. So something really important to keep track of, that it's a reserved word. I use it because I like to, if this was just name, and actually the type is going to be a string, and it's an uppercase because it's Java, right? So this, what I would have to do instead is say this dot name equals name. And there's some people who like that. you'll see this pop up a lot, but I don't know. I don't like that, the ambiguity of it. So what I do is I say, new name or updated name or something like along the lines of that. Yeah. So that's going to be based on maybe the company that you work with or work for, or the people that you're working with. But as if this is like a personal project, then that's just a matter of preference, and it's something to be mindful about. As you're working with others. Then we have our new account. And in this case, I'm camel casing things, as opposed to the private parts of the class are underbarred. And so right now I'm mixing those types. And so, somebody might be looking at this piece of code and they might think that two separate people working on it, because these are two very distinct styles. And so if I wanted to match, I would just change this to an underbar. Right. But depending on who you're working with, that's going to be a style thing. And then we need the type, which is an integer. And then we need our sorry, I'm using Jeff's server, and my network connection is apparently not the greatest right now. Okay, so then we're gonna stick our new account here, and then we're gonna stick our balance here. Cool. So there's our overloaded. So there's our overloaded constructor there. And then so now what else we got? We have our setters and our getters. And then we have this withdrawal and deposit, which will also be very much setters and getters, right? So the get balance is just going to give us, we're going to get the balance and we're going to return it. The set account number, right? The set account number is maybe if somebody called this default constructor, we need to go in and be able to set this. And maybe we need to set all of the other things as well. So maybe we need setters for everything. And then we have our withdrawal and deposit. So maybe we use, when we are using this default constructor, that we use the deposit because we start at 0, and we use the account the set account num. So now we've set both of these, both the account number and the balance. Right, balance was deposit, and account number was set account number. So then the only thing that's not set is the name. So maybe we only need to make a setter for just the name, besides what's listed here. Right. Okay. So I'm just going to copy pasta these things. And it's important to think of, what kind of arguments are you going to take? And what are you going to, so what kind of arguments are you going to take, and what are you going to return? So right now, I'm just making skeletons. I'm making the bare minimum of what's needed. So deposit, and this is a toss-up, right? You could make a deposit just void. You could make a deposit that's returns of type Boolean that says whether or not the deposit happened or not. You could make it a deposit where it returns the balance. But if you notice, we have a get balance. So if somebody really wanted, like for example, a lot of ATMs will prompt you if you want a receipt. And only if you say yes, will then give you your balance. Otherwise it doesn't. And so if you're depositing and you don't care about how much money you have in your account, maybe you don't bother. And because we have this get balance functionality for whoever's using us, we can just have deposit be void. So let's do that. For withdrawal though, withdrawal is a different case, because so you can always deposit money, hopefully, or deposit nothing, right? The deposit could always complete successfully by not depositing any money. Versus withdrawal, withdrawal will, if somebody asks for a certain amount of money, then you would expect that either it does or it doesn't do that. If there's insufficient funds, maybe you have some kind of exception that's insufficient funds, or that whatever the console or the environment where somebody is interacting, pressing the big withdraw button, that it looks at the return status of this method that tells it whether or not there's money to withdraw, and that if you say not to withdraw, so like for example, somebody goes to request the withdrawal, it says insufficient funds, that it doesn't then do the withdrawal. So you should make sure that inside of your withdrawal method that you don't automatically assume that they withdrawed that money. So in this case, we're gonna essentially behave as if it was a debit, where we stop at 0. And so if they request, if they have $10 in their account and they request 15, that you just say no, and that they would have to check their balance and then withdraw the proper amount. So here we're just going to say a Boolean. Okay. Get balance, right? This is a getter, so it's going to be the type of balance, which happens to be double. And then set account number. This is another one of those things that maybe you need feedback, maybe not. But each bank account instance doesn't know about the other instances. So, for example, if you had duplicate bank account numbers, the class itself has no way of knowing that. It's the bank's responsibility to maintain that and to make sure that they're not handing out duplicate bank account numbers. So here, this should hopefully always be successful. And we can also always throw an exception. If we're ever writing these and something doesn't quite match up with our skeleton, we can always throw the exception and then catch it, or have somebody else catch it later. So we don't necessarily have to give everything back in the return value. So yeah, let's start with the low-hanging fruit, get balance. We just say return, and it's literally us just returning this balance. And you'll see a lot of people here will also say this dot balance. It's synonymous in this scope, that this dot balance and balance is exactly the same thing. Set account number. So this might be something where you might check the balance. Oh, in order to set the account number, you need to actually get the account number. So here we're going to say it's of type int, and then we will say new _ account number. And then here, right, here we might say so here we could just assign it directly. But if we wanted to do some kind of bounds checking beforehand, like maybe they put in a negative number and we never want it to be, only want it to be -1 if it's invalid. Then what we could say is we could say, hey, if this thing is below 0, I don't know, do we want 0 to be a valid bank account number? That's something to be mindful. You just change it to make that the case. And this is one of those things that we could make this an if else, or we could return. So, and I'll show you what both look like. Even though it's void, we can return to say that we're done doing something. So here we would just set account number equals -1. So that the invalid state will always be -1. That if they for example passed a -99, that we would just store it as -1. And then this else would be if it's 0 or if it's positive, then we're actually going to set it. So instead, if we wanted to do this, we could also just say return. If I could type return. And then we could get rid of this else. And now what happens, Now what happens is that if it happens to be negative, we set it and then we return, and then this code never runs. But if it's positive, this condition is not met, it skips over it and it runs this. Cool. So there's our account number. And notice that if we didn't care about doing the balance checking, that this whole method would just be one line. And it would literally just be this line right here. But doing the balance checking is really important, because now when you go to inspect the variables, if it's positive and -1, then you're like, okay, cool, everything's behaving properly. But if for some reason you look in your account number and it's negative, some gnarly number, you know that something's gone awry somewhere and something's going in and mucking with your account number without your knowledge. And so, for example, if you also had some kind of algorithm or something that determined whether or not something was a valid bank account. So, for example, credit card numbers, there's an algorithm that determines whether or not they're valid or not, which is why sometimes if you're typing in on a website a credit card number, they can immediately say that's an invalid credit card number. They're not actually going to the bank and saying, hey, is this a card that you have? Is this a valid number that you have? What they're doing is that they're checking to make sure that it's a valid number. And so you could do the same kind of thing here, where if you knew if the bank had a set like distribution of bank account numbers and somebody had given you one that was invalid, you could check it here and you could set the bank account number to an invalid state. That way they could check, they could get it and say, oh yeah, it's invalid. Yeah, so you could add more checks in here, and that's highly suggestive when you're working with classes, is putting in as many checks as possible to figure out how things could be misused or how things could break. Yeah, and then withdrawal. So we could say, so let's just make a return false for nothing happened. So if we say, oh, and then withdrawal, they're going to be requesting a certain amount. And so this is one of those tricky things. Like if you walk into a physical bank, you can request cents. You could say like, I want to withdraw $5.50. But with an ATM, right, things are in distributions of like $5 or whatever, depending on the ATM. So in this case, we're just going to say, we're just going to say that this is going to work for both cases, that a teller could use this and then also an ATM could use this. So we're just going to say amount that they're going to pull out. And so then we're just going to say is if balance is greater than or equal to amount, then that means that we can proceed. Right, we could actually withdraw the money. So we could say balance minus equals the amount. Right, so this is another form of bound checking, that we're making sure that this is a valid state for us to be in before we do it. And so we could also rewrite this as, you know, as balance minus amount is greater than or equal to 0, for example. That would be exactly the same condition. And then we would return true to indicate that we have in fact, and maybe if you return true, that tells the ATM to actually distribute the money that they've requested. If it returns false, it prints out the error, insufficient funds, and it doesn't give them any money. But depending on where this class exists, you might here do that physical operation. Or you might just return true or false to tell the teller, whether or not it's an automated teller or a real teller, that that they can withdraw that money. Cool. So there's our withdrawal. Now deposit. So deposit, well, we need to know how much they deposit. And this again might be you know, dollars and cents. So we're gonna do something very similar here. And after, maybe before you do write all of this code, maybe you do write all of the Java doc in advance. The primary reason why I'm not dropping in all of the Java doc is then you can't see everything. Notice that right now, in this example, you can see the whole slide. I mean, you can see the whole class. That wouldn't really be possible if I had Java docs. You would see like 1 or 2 of these methods. Yeah, so that's the reason why. Also, because I'm feeling lazy. But it's really important to do that Java doc. So if this was an assignment, for example, or this was something that I was working on as a project that I actually cared about and I was doing something useful, that I would, in this case, even though the code is fairly small, I'd probably have just as much or more comments than code, because very quickly some of these things can get out of hand, and maybe I need to explain all of these bounds checking, because maybe somebody's trying to use my bank account class and they're using it for like a credit card account, and they don't understand why they can't withdraw more money than they have in their account. And it's like, well, because this withdrawal was written with the intention of it being used as a debit situation instead of a credit situation. So maybe you have a withdrawal debit and a withdrawal credit, something like that. But right now it's just this one. And so in the comments in that Java doc, I could explain that. I could say, yeah, this withdrawal is for debit, not for credit. Okay, cool. So let's make our deposit. And so deposit here, we might make sure, we might do some bounds checking to make sure that somebody isn't trying to be sneaky about the system. And so again, we might check something about amount. We might say like, hey, is the amount, we might make sure that the amount is actually greater than 0, right? Because if they put in some negative number, then it's a withdrawal. And we don't want that to happen, right? Or sorry, I flipped it. So if the amount, yeah, so actually that's what we're gonna do. We're gonna say if the amount is greater than 0, which means that there is a valid amount, then we do the actual deposit. And we say balance plus equals the amount. But if it's negative, what happens is we just skip over it and we just return. So if somebody passed in a negative deposit, we're just gonna ignore it. And this way it prevents us from doing weird things, right? Like if somebody was doing a withdrawal and for some reason they were calling deposit, that we just ignore them. So let's make sure we didn't make any mistakes. I have an extra, line 13, I have an extra comma. Right there. Right, compiles must be good. So now we can take a look at our Java, at our bank, at our bank. Yeah, that was to be expected. Okay, so let's go back to that one. That was what we had written beforehand, and we hadn't checked it if it compiled or not because we hadn't written bank account first. And so right now we have, and so now we have to actually match the, and this is just an example of poor copy pasting. So it was get balance, right? Or is it get account num? Oh, right, we haven't written that one yet. So let's do that. So we have a get balance, but we don't have a get account number, and that's expected here. So let's just copy pasta this guy. And so we need to match up the types, right? So it's the type for it is going to be an integer. And we want to make the name, and we're going to have to also change it in bank. We're going to make those match. Right. Notice that all I'm doing, literally the getter is exactly the same. All I'm doing is changing the names and the types of things. So there. So now we have a get account number. So we're going to go over here. Cool. Okay. And we gotta save this guy, close that guy. Compiles, must be good. Compiles. Oh, I am an open bank account, I'm missing a return. So let's take a look. So I did this example a little bit backwards. I probably should have started with bank account, got it solid, and then, yes. So here we needed to return the account number. So return and so here we're going to say this -1, right? Because we've incremented it, and so this here is going to be the bank account here, and then we need to call this get account number. Cool. And right now it's just using the default constructor, so that's to be expected, but it's not going to do much. All right, compiles must be good. Yeah, so that's the bank account example, where we have this class bank account, and then we have a bank class, and it makes multiple bank accounts. And so you can do this, and you can keep chaining them. You can have classes with classes inside, and those classes could have classes inside, and so on and so forth. Hopefully that's been useful. Yeah, that's the bank account example. And I will post this up on GitHub for all of you to be able to reference it, because looking at it in the recording isn't particularly useful. Yeah, so we had already covered classes, members and methods. And just as a normal exercise, this is something I encourage all of you to do just all the time, is look around your world and or your room or your house that you're stuck in, and think about, pick two things at random, and then think about all the ways in which they are similar. Maybe it's just they're spatially, they're both in the same room, or they both have some meaning to you in some way. But maybe they're colors, that there are attributes of their colors that make them different. So not only things that make them the same, but things that make them different, right? They have color, and so that's the thing that they share. But the thing that is different about them is that their colors are different. And then also for the methods part, so that was for the members part. For the methods part, think about ways that you interact with them. In order to interact with them, are there buttons that you press on both of them? Do you shake them to make them exciting to use? Are they all snow globes, or is it some kind of toy? Yeah, how do you interact with it? Do you replace the batteries in them? Things like that. Those could be methods, the ways that you interact with them. So that's just a really important mental exercise to do, because that'll help you be more confident when you're programming, when you're writing in class, of immediately going, okay, well, it has these attributes, or these things of these classification have these attributes, so those are going to be the members of them, and then all of these things are interacted or could be interacted with in these ways. I'm going to write those as methods. So that's something that I see a lot of students struggle with, and so that's why I'm just saying pick everyday objects and just practice that in your head, and maybe for funsies write a program that does that, or that the class, write a class that does that, and then maybe find some data set somewhere that already has all that information for you. I know some people that they've actually written code to help them organize their things in their kitchen, to be able to group them in classifications, and then from that then allowed them to organize their kitchen. But they first wrote the code to be able to do that. So it's an important mental exercise, and just a fun exercise to do for coding purposes. Yeah, so I'll see you around. Feel free to email me if you have any questions about anything. I'm pretty much available a lot. And wash your hands and stay put.